Hello and welcome to the lecture on Lighthouse Project at Indore. My name is Shailesh Agrawal, Executive Director, Building Materials and Technology Promotion Council, and I'm going to educate you all through this presentation about the field level implementation of innovative construction system being used in this Lighthouse project, including design basis, materials, manufacturing, structural drawings, detailing, and actual site photographs explaining the different construction stages. The outline of my presentation is as follows. Starting from Global Housing Technology Challenge India and Lighthouse projects, I will explain you technology in terms of various structural elements, namely foundation system, structural system, floor slash roof slab system, and wall panels, followed by construction activities at site. Ministry of Housing and Urban Affairs, Government of India, organized Global Housing Technology Challenge India on 2nd and 3rd March 2019, in which a Construction Technology India Expo was organized, which was inaugurated by Honorable Prime Minister of India. The basic objective of Global Housing Technology Challenge India was to identify, evaluate, and shortlist proven demonstrable technologies for mass housing, which can help build maximum number of houses in minimum time and minimum cost. Through the challenge, we could create a basket of 54 such technologies, which are broadly classified into these 6 broad categories, which are shown in this slide, namely precast concrete construction, 2D and 3D, light gauge steel structural system and pre-engineered steel structural system, prefabricated sandwich panel system, monolithic concrete construction system, and a stained place formwork system. In Indore, we are using a prefabricated sandwich panel system, and through this presentation, I would be explaining you this prefabricated sandwich panel system. Before getting into Indore, let me just briefly tell you about the 6 lighthouse projects which are being implemented at present and in 6 states of India at these 6 places. All these projects are using 6 different technologies under these 6 broad categories, which I just explained you. And the structural configuration also varies from 6-story to 14-story. In Indore, we are constructing 1,024 houses in a stilt plus 8-story configuration. The Indore project, if you see, this is the layout. The total plot area is around 41,000 square meter, and out of which 10% is kept as a green. There are 8 blocks in S+8 configuration with 1,024 houses. Along with basic and social infrastructure. If you look at the 2 typical floor plan, you will see that there are 16 dwelling units at each floor of the building block with provisions of staircase wells and lift wells. Have a look at the dwelling unit plan. Each dwelling unit consists of a bedroom and a living hall, along with kitchen, a toilet, and a WC, with a separate access from both the rooms to toilet and WC. It is to be mentioned here that the typical dwelling unit plan given here complies to the National Building Code 2016 space norms, which specifies minimum sizes of room, along with the height of the room, height of the kitchen, width of a staircase, etc. for EWS category. In addition to conformance to NBC 2016 space norm for EWS category, there are other special features included in the lighthouse projects, namely the project is to be developed under Griha Green rating. The use of renewable resources in terms of rainwater harvesting and solar lighting is also included in the project. Solid waste management, sewage treatment plant with recycling of water, and firefighting services are also as per prevailing Indian standards and to bring sustainable practices. The overall technology being used here is a hybrid technology, which comprises of steel frame structure with walls of a prefabricated sandwich panel system. But before explaining this technology to you, let me just briefly touch upon the prevalent construction systems being used world over. As you can see on the left-hand side, there are two pictures. One is a load-bearing structure, which is primarily a load-bearing brick masonry wall or any other masonry wall along with cast in situ RCC slab. So this is quite prevalent system earlier, and now this system is being replaced by cast in situ RCC framed structure. And framed structure comprises of beam and columns along with cast in situ RCC slab. So these two are the most prevalent system all over the world, and you all will agree with me that these systems are time consuming. At the same time, there is a lot of wastage of material. They are dependent on labor, generates a lot of dust and not amenable to the environment. And it is high time that we shift our gears from these construction systems in vogue to something new, which can help build faster without compromising structure and functional performance. So here, this is one new system where we are using, the fabricated factory-built steel structure for the frame, along with the prefabricated sandwich panel system for walls. This prefabricated sandwich system is an innovative system which is being used for the first time in India, and these are factory-made wall panels replacing, brick masonry and mortar walling construction. And this sandwich panel system can be used as a load-bearing and non-load-bearing walling system. But in this project, it is being used along with the steel frame structure because it is a high-rise structure of steel plus 8. Now, let me explain the technologies in terms of various structural elements being used in this particular project of Indore. Just to explain you what does structural element mean, any building can be divided into two structures. One is superstructure and another one is substructure. Substructure is what we call below ground level, and above ground level is called superstructure. So substructure comprises of a foundation followed by a column up to the plinth, and above plinth starts your superstructure. So this is called foundation, and above plinth, what you have is a vertical member, which is a load-carrying member, which is called column. Then the horizontal member, again, it is a load-carrying structural member, which is called beam. And this beam and column together makes a structural system. Basically, this is the skeleton of any building. Okay, once the skeleton is made, the floors, the floors may use different kind of technology. And then you have the walls, and here we are using the innovative wall panels. So the technologies being used for each of these structural elements will be explained in subsequent slide to all of you. Foundation, if we talk about foundation, we are keeping conventional here because of soil conditions, and so foundation is greatly dependent on geotechnical investigation, bearing capacity of that region, along with the subsurface strata and water table. So for this project, Indore being a rocky terrain, the isolated footings and combined RCC footings are proposed along with the RCC columns up to plinth height. Once you reach the plinth level, all the columns are connected through plinth beam at the plinth level. And above plinth, we put hot rolled factory-made build-up sections, which are of steel, and then over that slab is being cast, and walls are being again factory-made sandwich panel walling system. So foundation is conventional, as you will see in any other project, comprising of RCC footing. Structural system, as I explained you, structural system is nothing but a skeleton of a building comprising of beam and column. And as you can see, these are hot rolled steel built up I sections, which are fabricated in the factory, basically in a steel factory. So all these things being fabricated in the factory are brought to the site, aligned, erected, and assembled to create a structure of this kind. And later you can put the slabs and walling system for this. Sometimes this system is also known as a pre-engineered building system. When you talk about floors or roof, you will find here that we are using a deck slab. It is a composite kind of slab. This deck slab comprises of a deck sheet, which is a profile sheet. If you see from here, this is a profile deck sheet made up of steel, galvanized steel. So you put a steel deck sheet over which a nominal reinforcement is placed along with the concrete screed to construct a floor. And this floor is also can be cast speedily because you don't require any shuttering here, and this deck sheet acts as a formwork. In this project, the innovation is about not only about the framing, steel structural framing system being used. In addition to this, we are using a very innovative wall panel system, which is called prefabricated sandwich panel system. These panels, as you can see here, comprise, it is called sandwich panel system because there is a core, which you see here. This is a core which is sandwiched between two layers, and these two layers are of fiber cement board or calcium silicate board, and in between you fill it with the lightweight concrete. This lightweight concrete is again a special concrete which is made of EPS granules. EPS is expanded polystyrene plus cement, fly ash, and some other adhesive. Okay, and this core material is posed in a slurry state under pressure into the preset molds, and these preset molds are then cured, and then panels are made. So entire thing is done in the factory, and this is how these are being stacked in the factory, and this is how they are being put as a wall panel. Okay, so this is a steel frame which comprises of built up factory made steel beam and columns, and the walls are of this prefabricated sandwich panel, which comprises of fiber cement board layers with a core of lightweight comprising of elevated or lightweight concrete. A typical manufacturing plant, if you want to know, has these stages. Automatically there are silos in which the ingredients for making this sandwich panel are stored, and through a computer these ingredients are mixed, and then through a mixture they are poured in a preset molds, and then through vibration and curing these columns are stacked, and then once the curing is complete, they are ready for packaging and shipping or transporting to the sites for erection purposes. So this is a typical manufacturing plant, which is very simple. You have mixing all the materials electronically through computer-aided center, and then in a preset mold you pour the material, do the vibration, split the panels, do the curing, and then they are ready to move to the sites. Have a look at the typical factory setup. It's a small factory setup, and as you can see, these are the molds in which these are the preset molds in which elevated concrete or a special type of concrete through computerized system is poured. And once this is poured, then it looks like this, and then it is left for curing, and then later they are stacked here and ready for transport. The typical dimensions of this, again, these can be customized as per customer needs, but for the lighthouse project at Indore, the length of this panel is up to a story height, which is 2.44 meters, and the width of each panel is around 2 feet, 610 mm. The thickness of each panel varies from 50 to 250 mm depending upon the dimensions. Again, as I told you, these are customized panels, and depending upon the application, whether you are using it for residential purposes or for any other purposes, the thickness can vary. For Indore project, the thickness of panel being used is 120 mm for external walls and 90 mm for internal walls. Another important thing here is these all these panels come with tongue and groove kind of system, and they perfectly fit into each other through slide and lock system. So these walls can be easily erected at the site with manually with ease. Also, wherever we have L or T joint at any joint, additional threading elements are also being produced in the factory, which are 60 mm thick to conceal those joints and to encase the steel structure. As far as weight of these panels are concerned, you can see the panels which we are using in this particular project weigh from 74 kgs to 135 kgs. The density of core is 580 kg per meter cube, and density of overall wall panel is 670 kg per meter cube. So 74 to 135 kg can be easily lifted by a person of the size of this size of panel, which is 3 meter height and 610 millimeter wide. Just to give you more details about these panels, how these panels are being fixed, here you can see these panels are being fixed with the soffit of a beam, which is RCC beam, through a U-type channel, through this kind of dowel bars which are inserted and then grouted in the beam. If you look at the steel structure, the panels, as I already told you, tongue and groove system, so they can be fixed in a slide and lock through slide and lock arrangement. Then there are these red things which you see are U-type channels which are used to hold these wall panels with the steel structures, and you can also use additional clips which can be welded with the steel columns and beams to hold these panels firmly with the column and beam floors. Okay, and when you join these two panels together, are joined in this fashion. The dowel bar at 45 degrees is inserted in a core material, and through that core material is inserted into these columns. So to have integral action, in addition to slide lock arrangement, both the panels are jointed together through a steel dowel bars, which is inserted through a hammer at a 45 degree. And because this being a lightweight concrete with the EPS granules, this can be easily nailed by through a hammer. So this is one jointing, and with the steel beam, if you want to put it, you have to put U channels which are welded on the beam, and then you can put these panels. If you want to put it on a concrete beam, then this is the kind of arrangement you have to do. Then typical L and T joints, if you want to know, this is a typical T and L joint. Wherever you have a joint, so in between the joint, to plug the gap between the joints, you have to fill it with the exterior grade superfine ready mix plaster, and you have to finish it with putty, and then there is a tape, anti-crack fiber tape, which is put to give it uniform smooth surface. It is done so that there is no ingress of water through the joints. Advantages of these systems are plenty. First of all, this is a dry walling system, and in dry walling system, you are not using any water. And if you see a typical brick wall construction, you see mortar, water, labor, shuttering, and scaffolding is being used. Here, manually, you can just put these panels with 2 or 3 persons. The entire wall can be erected within no time. And being dry walling system, there is water conservation, and it brings speed to the construction. Sandwich panel system, as I told you, are very light in weight, and being light in weight, this brings a source efficiency, better light. Wall panels, contribute very less to the dead load, thereby economizing the whole structural design and analysis. Foundations are also lighter, and being a core of EPS or elevated concrete, this is better as far as functional performance is concerned in terms of thermal efficiency, in terms of acoustics and energy efficiency as well. Essential requirements of this innovative technology is that joint of these panels need to be carefully seen and carefully detailed. They need to be perfectly locked, because if you don't lock them properly, so there may be precipitation of failure, because if it is loosely connected, then one failure of one joint will lead to the failure of other joints. So the joints need to be properly locked with cement, glue, double bars, exterior gate, superfine plaster, and the mechanism. And it may look slightly tedious, but once the labor work, once your workforce is trained, it can be done within no time. Secondly, because these are factory-made panels made in the factory, so you have, for putting services, you need to do the cutting and chiseling of panels, and that also need to be done through a skilled workforce, and you require special tools and machinery for this. For floors and roofs, these panels can also be used as floor and roofs, but for this particular project, we are using a composite deck slab or deck roof, but otherwise these panels can also be used as a roof panel with nominal reinforcement and screed. Again, this project is given on a design and build basis, and the technology provider is a Rising Japan Infra Private Limited, and the agency who is executing the project is KPR Project on Private Limited Nasik. Design and build basis means here is that the design basis and the structural design along with analysis need to be carried out by the company and the technology provider, because it's a new technology and it is first time mass scale field and implementation. So design is also proposed by the agency, but it has to comply with the contract document, with the specifications being provided by the implementation agency, and has to comply with national and international standard. Once the design is done or completed, then the design is being vetted by IITs, because being first time implementation of technology, for keeping checks and balances, the design being vetted by IITs. And once they approve the design, the structural drawings are given to the agency, which can then be converted into the construction drawings. So let me briefly tell you about the design basis, which is very important part of any project, and because it decides the size of your members, the reinforcement. If it is a RCC structure, then what kind of reinforcement you are using. If it is a steel structure, then what would be the dimensions of your joints, how you are connecting the joints, what kind of nut and bolts are required, what kind of anchor bolts and things of that are required. So you need to first prepare a design basis report. And in design basis report, first of all, you have to spell out the kind of structure you are going to design. So here it is a RC steel hybrid structure, because few places at lift wells at lift wells and staircases wells are of RCC, and rest of the structure is steel beam column structure. So it is a hybrid structure of steel and RCC. Also, up to substructure, the foundation is purely RCC. So the code used is IS 456 for RCC, and for steel, the code used is IS 800. So both the codes are to be incorporated in the design basis. As I told you that Indore, being in a rocky terrain, the bearing capacity is very high, which is 40 ton per meter square. However, the foundation depth is kept as minimum 2 meter, because it's a high-rise structure, and to counter overturning, a minimum depth of foundation has to be kept, again based on Indian standards. Foundation being RCC, so isolated and combined footings are being proposed here as per the relevant Indian standard, which is 1080, and raft foundation is also proposed as per 2950. Now, to ascertain loads, there are standards available. Live load, depending upon the use, you find the live load. It is a residential structure, so live load is around 150 kg per meter square, and then you have to calculate wind and earthquake load. So wind load you need to refer the wind hazard map, which is given at right hand side of your screen, which is a wind hazard map taken from Vulnerability Atlas of India of BMTBC, and depending upon the location, you can find out the basic wind speed. So for in case of Indore, the basic wind speed is 47 meter per second, and this basic wind speed is multiplied with several modifiers, based on the topography of the region, based on the importance of the building, based on the size and dimension of your building, based on the risk coefficient, and based on these modifier and basic wind speed, you can arrive at the design wind speed and wind pressures, and those wind pressures are used for analysis and design of your structure. Earthquake is also very important, and earthquake loads are also be taken into consideration. As you can see in this map, India, this is again a map from Vulnerability Atlas of India of Building Materials and Technology Promotion Council, and this map is as per NBC National Building Code of 2016. So India is divided into 4 zones, starting from zone 2 to zone 5, and Indore falls in zone 3. And based on this zone, you have to calculate the lateral forces lateral seismic forces for which your building need to be designed. And the calculation is as follows. What you have to do is you have to find out the design horizontal seismic coefficient, which is a product of your zone, and then the type of building you are using, and the importance of your building, and the response reduction factor. Response reduction factor ensure the ductile behavior during earthquake. So here, response reduction factor being used is 4, because the building is designed as a dual system having ductile RCC structural walls and few spatial movement frames. Okay, so with this you can arrive at design seismic coefficient, and that design seismic coefficient, when multiplied with the seismic weight or the total weight of the building, will give you the base shear for which your building need to be designed. Also, when you do the analysis, boundary conditions are very important. So steel columns are assumed to be pinned at the top of the RC pedestal, that is the plinth beam, and some columns column beam joints are assumed as rigid joint to cater for lateral loads, and others as pin joint. So all kinds of jointing system are available for the design basis in this, and floor being DAC slab with screed. So diaphragm action is ensured. Rigid diaphragm action is accounted for in horizontal direction at the floor levels as per the IS 1893 code. The most important code when you are doing a design basis for earthquake is IS 1893 and 13920. So both the codes are to be taken into account when you are preparing the design basis report. And based on this design basis report, you have to carry out the structural analysis, and there are a number of codes which need to be complied with. There is the exhaustive list for calculation of loads. You have IS 875. There are different parts, and for earthquake load you have different code. For structural steel you have IS 800. Then for RCC design, you have IS 456, which is the most important code for RCC design. And then for reinforcement, you have a code IS 1786. And for ductile detailing, as I told you, if you're doing for RCC structure, then there is a code 13920. Otherwise, you can also refer 4326, which gives you general guidelines for earthquake resistant design and construction. For foundation, again, there is an exhaustive list for Indian standards, depending upon the foundation you are using. So if you are using a raft foundation, then we have a standard called 2950, and if you are using the foundation other than raft, then 1904 or 1080 is the standard. All these standards need to be followed religiously, because they give you the guidelines and provisions to make your building serviceable and durable, as well as efficient. So depending upon these load conditions, depending upon the design basis, and following all these codes and incorporating the provisions being given in these codes, you can always use a CAD software to create a model of your building. So this is the model of the building, which is it is a 3D model. You can also have a 2D model, which can be prepared in any of the softwares. There are a number of softwares nowadays available. Some of them are StatPro, ETAP, SAFE, SAP, Abacus, and any of the software can be used for detailed structural analysis. And the structural analysis is carried out for worst possible load scenario, and the load combinations for which you have to carry out the analysis are listed here. You will find here that there are 13 load combinations when you consider earthquake load, and similarly for wind there are 30 load combinations. For these so many load combination, you have to carry out a structural analysis, and then you have to do the design for the worst possible load scenario. Also, as per the codal requirements, you can carry out either 2D analysis or 3D analysis, and that analysis can be static, dynamic, linear, or non-linear. There is another important software which is frequently used is AutoCAD, which is used for drafting purposes, for making architecture and structural drawings, and that software also we as users we must have a little knowledge of AutoCAD softwares. And when you do the structural analysis and design, the whole premise is to have limited state of collapse and limited state of serviceability. So limited state of collapse means that during the service life of building, no matter whatever is the force, your building should never collapse. It means there should not be any life-threatening collapse during the service life of the building. That is the collapse of the building need to be avoided, and accordingly we have to design and incorporate factors and other stipulations given in code. Another thing is limited state of serviceability, and no point of time your building should remain unserviceable. Okay, so deflection criteria, depths, joint details, and all these things are to be designed based on these two limited states. And the codes guiding codes for steel and RCC design are IS 456 for RCC design and IS 800 for steel design. Now let me come to the construction sequence. Again, construction sequence will be explained to you in terms of structural elements. Again, structural elements can be divided into two: substructure and superstructure categories. Substructure comprises of foundation, whereas superstructure comprises of structural system, which is a framing system, then floors and wall panel, and in the last I will show you how to do how to put services in these innovative construction systems. So first and foremost thing is to look at the structural drawing, because the structural drawings will form the basis of your construction activities which you are planning at the site. So this is a typical foundation layout, and this shows you the basic foundation plan here. As you can see, these are the basic foundation pit, and then these are the location of columns. And if you cut the section, so the reinforcement in each column, wherever you have a raft, then what is the reinforcement in the raft, that is also being given here. How this foundation is to be connected with the plinth, and the above column is also given in this table, in this drawing. So one has to refer to this structural drawing quite a few times to translate this drawing at the site by doing the proper layout, and by properly marking the center lines and center points of these columns, and then putting the reinforcement, putting the mold, shuttering, putting the reinforcement, doing the casting, and then reaching up to the plinth level. This is over the footing you will have a column. So this layout shows you the layout of the columns which are directly coming over the footing. So you can see this. So these are the locations of the columns. So once you have done the foundation slab, then you have to put the columns over there. So these are the locations of the column, and accordingly you have to put the reinforcement gauge of those columns. Okay, and the schedule is also given. These columns can be categorized depending upon the the kind of columns you have. So if you have, suppose this is a P1 column, and then there are other kind of columns, so you can categorize, and depending upon, you can take the schedule of reinforcement. Anchor bolts, because here we are using RCC footing, then RCC column up to plinth, and over that we are putting the steel column. So anchor bolts, location of anchor bolts are also part of foundation plan. So this slide shows you the anchor bolt and base plate details. So as you can see in this, this shows a typical column, base plate detail with the anchor bolts. So these anchor bolts positions need to be fixed while you are putting a column, pedestal or stem column over your foundation slab. And how these anchor bolts are to be put are given here. This is again a band of this kind is to be given, and what is the height, what is this length, and what is this length is again given in the design. This is a plinth level framing plan, because once you reach at the plinth level, it is always advisable to connect all the columns which are coming up to the plinth level with, from the foundation slab, all the columns which are coming up to the plinth level, they need to be connected together at the plinth level. And, in order to have better seismic resistance, it is always advisable to connect all the columns at the plinth level through plinth beam. This will ensure box-like action, and in the event of an earthquake or any settlement, the entire structure will behave in unison monolithically and ensure monolithic box-like action, which is good for seismic resistance. So this shows a typical plinth level plan. These are the having done that foundation slab, these are the columns, foundation columns, and then these are the dotted line shows you the plinth level plinth beams. The grade of the concrete which is to be used has to be pre-decided depending upon the design. So here M25, again, as I told you, that higher grade of concrete is being used. Normally M25 and M30 grade of concrete is used for RCC footing and raft foundation and pin beam, because these construction is being done below ground level, and sometimes because of ingress of water and because of deleterious material available in the soil, you need to have a concrete grade or higher concrete grade which is impermeable, which is durable, and which inhibits corrosion of reinforcement. And normally we go for mixed design. So here also mixed design is being done, and reinforcement steel also has to strictly comply with the code. And the code for reinforcement steel is IS 1786, and here the steel being used is Fe 500. 500 represents the yield strength of the bar being used, which is 500 Newton per mm square. Concrete mix design is again done by the academic institution. Here in this case, it is a engineering college in Indore, and you can see the advantage of doing mixed design is that you can optimize the use of various materials, precious materials, I would say cement. So here consumption of cement can be optimized. You get here you are using 350 kg per cubic meter cement for M25. Water cement ratio is also optimized along with aggregate and other ratios. So instead of using nominal mix, we use this mix, which is obtained from the concrete mix design, which is 1:2.2:3.5. Normally, for M25, it is 1:1:2, and so instead of that, this is so that way you save a lot of material. Also, for early gain of strength, you use a plasticizer. So here also the plasticizer is being used, and sand being used is crushed stone sand. So it is again a manufacturing sand which is being used here. When you are doing a mass stable application of concrete, normally a batching plant is set up at the site, and batching plant ensures resource efficiency and optimization of building materials which is being used, and help in producing better quality concrete. So this is a computerized batching plant, and what you can see here is through these batch mixing, you can mix various materials and get the concrete made, and that concrete. These are the silos where material is being stored. Here, the aggregator being stored, and they are mixed and then transported through these transit mixtures to the site. The quality control lab is also established at the site for immediately testing the concrete and other material which is coming to the site. And typical testing laboratory have various equipments. It has concrete. This is a concrete cube mold, and this is a compression testing machine which helps in ascertaining the grade of concrete you are using. Then for water absorption and for ascertaining the moisture contents, you use a oven. And in addition to this, you have a lot of other equipments like sieves and all to find out, evaluate different properties of the materials being used at the site. Now let me come to the foundation, because it is a rocky terrain, so you have to first excavate. So for excavate, you have to use mechanical excavators, and sometimes you have to use drilling machines and all. If you encounter rocks, so as you can see here, this is a kind of drilling. When you encounter a rock and you have to reach to 2-meter height, then you have to cut that rock through these cutters and mechanical excavator. So the drawing is based on your structural drawings. You have to first do the excavation and create a pit, and in that pit you have to create a layout of your entire pedestal, foundation slab, and all those things, and then lay the reinforcement. You can see here, having done that pit, having excavated that pit, here the PCC is being laid here, as you can see, and then over PCC you will put the reinforcement, and then you will do the foundation slab, and then you will do the column up to plane. So the foundation work starts with PCC laying, and use of PCC is just to level the ground, so that your foundation is not laid on a undulated ground. So PCC is nothing but plain cement concrete of low-grade concrete, which is M10 in this case, and the thickness specified here is 110 mm. Having laid that PCC, what you do is you lay the reinforcement cage for footings. Okay, so here, as I told you, we are using isolated footing as well as combined footing, and we are also using raft in few places. And so this is how reinforcement is being played. And the vertical reinforcement which you see is the reinforcement of the column, which will come up to the ground level, up to the plinth level. And this reinforcement, vertical reinforcement, is also tied with the reinforcement of your foundation, so as to have continuity of reinforcement, and so as to have monolithic action and structural integrity as far as load transfer is concerned from column to the foundation slab. So this is also very must, and it has to be carefully detailed, so that these vertical bars are properly anchored with the horizontal reinforcement of slab. So having laid this reinforcement of column and foundation slab, you have to pour the concrete. So this is how concrete is being done. You can see here concreting is being done for the foundation slab, and what you see in between, we have in between we have a lift well and a staircase well. So wherever we have a staircase well and lift wells, there the raft foundation is also provided, because at staircases and at lift level load requirement is higher than in the normal areas of the building. So wherever there are staircases, these staircases are provided with the raft foundation of additional thickness of 500 mm. So you have a foundation isolated footing, and then you have an additional raft wherever you have our staircase well. Also, there is another important thing which you should notice here, because the entire thing is coming below ground level. So all these exposed surfaces here are provided with Kota stones, so as to minimize the ingress of water. So it's a kind of waterproofing arrangement which is done at the site by putting Kota stone below ground level on the exposed concrete surfaces. So here you see this is a shuttering and this is the reinforcement, and here concrete is being poured, and this is a Haitian cloth which is kept wet during the curing of this concrete. And this shows you a lift and a staircase well, where you have additional raft, and over that Kota stone is being laid forward. Now, once you have have the foundation slab is being laid, this is isolated footing, and here you have this raft. Then you put the shuttering or formwork for the column. So this is the formwork for the column. Reinforcement cage is then laid over this, and this reinforcement already laid reinforcement which is connected with foundation. The reinforcement of this column is connected with this reinforcement through splices and through stirrups. Sometimes it is welded as well, and then concrete is poured in this up to the plinth height. Okay, and once you do it up to the plinth height, so you come at the plinth level, then backfilling is done. At the plinth level, backfilling is done, and then again backfilling is done in the layers of 200 mm with proper compaction with water, so that the soil gets compacted. If you don't do this big backfilling properly, at a later stage, the soil may get settled, and once the soil gets settled, there will be a differential settlement leading to the cracks in different parts of the building. After doing the backfilling, you lay the reinforcement of these plinth beams. And as I told you that all the columns at the plinth level are connected with this plinth through these plinth beams at the plinth to have monolithic box-like action of the entire superstructure. And now this reinforcement will be terminated here with the anchor bolts, and over which you will put steel column which comes from the prefabricated steel column with a base plate, which will come from the factory and will put over the anchor bolts. This is a typical slide which shows you this is a template of the anchor bolts, because the base plate comes welded with the steel column and beams from the factory, so it has to be very accurate. So a template is created, and you see this is a dumpy label which ensures the proper labeling of your column. Or proper labeling of your anchor bolts, okay, and then anchor bolts are normally put through sleeves, and sleeves are slightly more than the diameter of the slab. The idea here is, by putting these sleeves, you will do the grouting, and then you will remove the sleeves. Okay, so this is how the fixing of anchor bolts with templates is being done, and then once the base plate is fixed, this is how. This is a template plate just to show you that once you put a column with a base plate here, then this will be fixed with the foundation through this nut and bolt arrangement. And the height, the length of this anchor bolt within the column, within the foundation, is again designed and given as a part of structural design, depending upon the diameter. Okay, and as I told you, there is a sleeve, and then you have to grout this anchor bolts in the columns. Okay, so let me show you here. This is how this is the shuttering of your plinth beam, and once shuttering concrete pouring is done, then this is how it looks like. So this is a plinth beam at the ground level, and over this your steel column will be erected, which will come directly from the factory. Now let me come, having done the foundation, let's come to the structural system. And again, here the project has come up to the foundation level, and very soon we will be starting erection of columns. So I will explain you the structural systems and other details through drawings, sketches, and text, because the on-site photographs are not available, because that work is yet to start. So structural system is, again, as I have been repeatedly telling you, is comprising of built-up eye sections, and these built-up eye sections are fabricated in the steel factory, which are made from steel sheet through machines, and typically they are hot rolled eye sections. And so once you have beam and column eye sections, they are erected, they are then connected properly through through gusset plates, angles, and nut and bolts, and then you lay the slab and then do the wall panels, install the wall panels, where we are using precast and panel system. This is again very important slide because the whole premise of this structure depends on how do you connect the foundation with the superstructure, which is a steel column. So this anchor bolt it plays a very important role, and so depending upon the dia, the length which is to be inserted within the foundation pedestal, and what is the threaded length is decided as per design. So if you are using a 16 dia anchor bolt, then this length is 400 meter, and the bend of 90 degree having a length of 100 is must, and this thickness, this length is around 100 So this need to be ensured so that there is no overturning, and this is connected with this RCC column properly, and giving smooth transfer of loads. And these anchor bolts, if you look at the plan, there are 4 anchor bolts, and I already showed you the template. Through that template, these anchor bolts are prefixed in the foundation and cast with the concrete column or pedestal stem column. And then once you erect the column, all you have to do is you have to put the nut and bolts. Okay. Then column beam connection, beam column connections, how you are doing the column splicing, all these things need to be properly designed as per Indian standards. So this slide, this particular slide shows you how the columns are being jointed together in length. Okay, so if you have to connect one column with the other column, this is how it is being done. So as you can see here, column are being spliced through these nut and bolts. There are, as you can see, there are 8 nut and bolts which are put on the plates which are welded on the web portion of the column. So the 2 columns in the length are connected together through the base plates, through the plates and nut and bolts. Similarly, if you have to connect the beam with the wall, the staircase wells and the lift core wells, you have a RCC shear wall, and there you have a beam. So how do we connect that steel beam with the column? That is this detail. And as you can see here, while casting the RCC structural element, you have to put a base plate through lug bars, and that steel plate is connected with the beam, with the web and flange of the beam, again with the web of the beam through nut and bolt. So this is the detail which is given, and through a cleat angle. So you put a angle, and that angle is connected with this base plate as well as with the web of the beam through nut and bolt. So that's how it is being connected. And all these joints, typical joints in the steel beam column, beam column are to be properly detailed, designed, and then put and decided. Now, the beam column joints and beam joints are again can be designed in 2 categories. One is a moment resting frame, and one is a shear and moment resting frame. So at few places you require that the joint should transfer moment as well as shear. So they are called shear and flexure connections. And at few places you require only moment transfer. So wherever you have a beam column connection with moment moment resting connections, though, you have to what you have to do, you have to connect the beam and column both at the flange level and at the web level through nut and bolts, and by putting a plate and both the in both the structural element, that is beam and column. So as you can see in this plan, as you can see in this plan, these are the nut and bolts which are being put in the flange and web portion of columns as here. And if you want to create a shear connection, then what you have to do is you have to have a cleat angle, which is through cleat you fix the web portion of the column with the web portion of the beam. So this is called only in the web you are doing, and when you are creating a moment connection, then you have to fix it at the web as well as at the flange level. there are very stringent requirements as far as material specification of steel is concerned, because these are being fabricated in the factory. So you have to use structural steel. This is a hot rolled steel built up sections, so it has to strictly conform to IS 800 and IS 7205 as regards fabrication and erection. Also, whenever we do a fabrication in the factory, there are tolerances for fabrication and dimensional accuracy. So again, there is a standard IS 725 which talks about tolerances. Similarly, while erection, what are the permissible tolerances need to conform to Indian standard, which is IS 12843. As regards material, its transportation, its erection, there is again a code which is giving how to stack the material, how to transport, assemble, erect, align for all these material. There are codes. Primarily, the code is IS 800, which need to be referred to for testing, quality, surface condition, protective treatment, and other things. All connection plates, once you are erecting a steel column and it is having a particular yield strength, so your connection plates and nut and bolts should also have similar yield strength. Otherwise, what would happen? Connection will fail first, or if their their strength is less, then that will fail first. So again, there are codes which help you deciding the yield strength of joint plates, angles, and other things. Anchor bolts play a very important role. They are also known as holding down bolts. So there is again they are high strength bolts having yield strength of at least 250 Newton per mm square, and there is again a code which need to be referred for that. As I told you, that for erection, you need to take utmost precautions, because the alignment of these steel columns is utmost important, and wherever required, you need to weld these steel columns. So welding has to be done following a code. For deck sheet, because we're using a deck sheet also, a particular grade of steel is to be used for metal deck sheet. And whenever we erect these steel columns and framing structure, you need to do proper bracing or shoring so as to provide lateral support to avoid any failure or any dislocation of these columns and beams and frames at the site. There should not be any gap in between, so all the joints are to be fixed properly and to be packed properly, so that in a later case there is no loosening of joints and there is no ingress of water leading to leakages and other things. Fabrication is to be done at the site, and it is not that you get the components and then you start erecting. You have to stack these. You have to first transport these material to the site. So there is a standard protocol which need to be followed for transporting these components to the site in a trailer. And then erect them at the site. Before erection, you have to stack these the fabricated components at the site. They should be properly numbered and arranged in such a fashion that depending upon the block or depending upon the column, you can just take that column and start erecting it. Also, normally you have to have a stacking at a clean site, because these are steel columns and they may be susceptible to corrosion because of water and other things. So you need to have it at a site where water should not accumulate. So the site where these are being stacked should be clean. Fasteners and small fittings shall also be stored under cover in dry condition, and any damage to the steel work during offloading and transportations need to be attended to, and there is again a standard available for restoring the damage, because these are heavy sections, and when you bring it to the site, there is a possibility that few of these columns and beams or structures structural elements may get damaged during transportation or storage erection. So again, you need to follow the column, follow the code. Also, the anchor bolts and all, wherever you are putting it with the concrete, you have to do the proper grouting, and you have to carry out the proper alignment. You have to have it in proper plumb. Always when you put a column base plate with the RCC concrete column, there is some space left, so that space need to be cleaned and filled with the non-shrink grout or with a stiff material. Now let me come to the steel columns, which are, once you have done the foundation, steel columns which are to be erected. So this particular slide shows you the steel column layout, and these columns are properly numbered like C1, C2, C3. So the C1, C2, C3 are of different sizes. So as you can see here, C1 has a web of this. This is the dimension of flange. So it is 350 by 10. It is 200 by 16. So these numbers are being done here, and by referring this structural drawing, you can readily know that which column need to be erected where. So whenever you erect a column, you look for this nomenclature of this column, and to be doubly sure, you have to see this dimension and then erect it accordingly. And what you see here, these are the lift course of RCC shear walls for staircases and lift course. So after that, you have to put a slab, and the details of floor slab are given in this slide. Here we are using a deck slab. So this is a this is factory made beams which are erected at the site, and over this what you do is you put a deck sheet, and the typical deck sheet profile is of this size, of this kind, and it is a 0.9 mm thick metal steel deck sheet, and which is put over the beams with the required bracing. And then what you do is you put a nominal reinforcement as per IS 456 and do a screed of 75 mm with M25 concrete, which create this kind of deck slab, and it is known as a deck slab. And using deck sheet avoids the shuttering for the slab. So these deck sheet slab can be laid very fast, and it requires less amount of concrete. It is all screed concrete with nominal reinforcement, so you save in material as well. Then this is a typical floor framing plan. Once you have, before laying the deck slab, you have to see the floor slopes. You have to maintain the proper slopes at the floor level. So this structural drawing shows you the slope level. So you have to maintain those slope levels. Then wherever you are getting a moment resting frame, or wherever you are getting a shear resting frame, all those details are also being given here. So depending upon this drawing, you have to properly lay your deck sheet and reinforcement and do the proper connection before laying the reinforcement screed. So typical floor framing plan is given here, and it also is supplied with the services. So wherever you have some fan box or any other services, that is also given in this plan, so that can also be put. A typical plan of laying of. Now let's move to wall panel, and this drawing shows the typical wall panel. So as you see here, this is one panel, this is another panel, and depending upon the size of your building and size of your rooms and kind of joints you have this kind of T joint, you have this kind of L joint, you have this kind of small joint, you have this kind of joint. So for all these are to be first numbered in the drawing, and then depending upon those number and depending upon that size and configuration, these are fabricated in the factory, those panels, and they are numbered in the factory and then brought to the site, and depending upon those numbers, these wall panels are being erected through a slide lock arrangement. Okay, so this is one panel, this is another panel, and then wherever you have L and T joint, you have to put a cladding panel as well. So through this drawing, you can see the number of that panel and accordingly erect those panels. This slide shows that how at the wherever there is a joint, T joint or L joint, what you have to do, because this is a I section, and the flange of I section will be seen, because of this, you have to put a cladding panel. So this is an additional cladding panel, which is again done in the factory. So this kind of factory panel, panel is to be inserted here, both at inside and outside, so as to encase this, exposed flange of I section. So it can occur either at the T or it can occur at the L. So if it is at the L, you have to put this kind of cladding. Here, this is a cladding. It can be done with the cladding panel here, and here you can do it with the concrete, and here this kind of panel can be put. So if you see it in the section, this is a mid corner. So mid corner is detailed like this. If you see in section, this is the edge. So this is your original panel, and then you have this specially made cladding panel, which is put like this. Okay, and if you have this kind of panel, then you have to put it like this. Okay. Now, construction and installation of wall panels, it's again very simple. What you have to do, for once you have reached the plinth level, then you start erecting the beam and steel beam and columns. Then you put the deck sheet and cast the slab. And once you cast the slab, your entire skeleton of the building is ready, and then only you start erecting these wall panels. Okay, and for fixing of these wall panels, you have to put the U channels on the floors, because under these U channels only, through these U channels only, you can fix these wall panels. Okay, and these wall panels are erected in plumb position, and the two panels are joined together with the steel double bars at 45 degrees, and then the panels, at the floor level and at the top of the floor level are fixed with beams and columns with the help of steel dowels and those U clips, those U clips, and then joints between those panels are fixed with superfine ready mix plaster, and then a putty is done and anti-crack fiber tape is being put. For fixing electrical and plumbing services, you have to cut groove like you do in normal construction through chisel, and you fix the pipes, the plumbing pipes, electrical pipes, and etc. And then you fill those grooves with superfine ready mix plaster. This is different stages, as you can see. This is a concrete building where these panels are being fixed. So this is typical panel of 600 mm wide and with a tongue groove system. So you put it them, you connect these two panels together through a double walls. With this also you put through a double wall. If you have a steel column, then you have to put a U clamp kind of thing, and you finish this like this. So in a typical steel building in Indore, we are going to have this kind of structure, and you can see. So this is a beam, this is a column which is of steel, built up steel section of hot rolled steel, and this is your deck sheet over which your slab of floors are laid, and once you lay this, then you put this wall panels. And these openings can be cut either in the factory or you can cut it at the site, and all the services are concealed within these wall panels. And all these wall panels come with tongue and groove kind of slide and lock arrangement, so they are being properly fixed. And wherever you have these joints, at these joints you will put a putty, anti-crack, and a grout. Okay, and wherever we have these joints, because this I section is protruding, so what you do is you put a cladding panel as well. Services, as I told you, that services is done in a conventional method. So this particular slide shows you how you do the chising and filling. And once you do the chising and filling, it can always be filled with the grouting and all. And this is how it looks at the later. Then you can fix the tiles as you fix in conventional way. And this is how it looks like. This is there are some other finishing items. So I want to stress here that these innovative systems are compatible to the Indian finishing items, so whether it is WC bath or it is vitrified tiles or any other tiles or UPVC frame or press steel door frame. So all these prevalent finishing items go well with these new innovative technologies as well. So you can put a Kota stone for flooring, you can put ceramic tiles, vitrified tiles, and glazed panels, and all these things are being done in this project as well. Other infrastructure items which are included in this project, besides social and physical infrastructure, are STP, sewage treatment plant, then street light with LEDs being done here, rainwater harvesting, and solid waste management is also included. Also, provisions for firefighting is being included in the project. These are few finished building abroad, and as you can see, any kind of shape and any kind of building can be made with this technology. These precast sandwich panel systems can be used standalone for making a building, but here being high rise, we have used hybrid structure where the frame is of steel and walls are of this innovative precast sandwich panel system. And schools, offices, barracks, affordable housing, high-rise structures, boundary walls, hospital, warehouses, parkings, any structure can be built with these technologies. Any architectural form can also be made with these kind of systems. Right now, that is all for this project. If you want to see the live status, if you want to really see the progress and learn about the various facets of these technologies as it gets implemented at the site, you can visit gstcindia.gov.in website and go to the tab of Live Labs, where you will find the live status of all these lighthouse projects. So you can go to project at Indore and see the pictures along with videos. I will also be covering the other details of the project as and when it comes through lectures. In case of any query or in case of any question, you can always write to us or contact us on the following address, which is given here. And you can also write to me at sk@bmtpc.org to know further details about this technology. Thank you very much.